Hey, in this video we're going to go over how to do integrals, what they mean, and a few easy examples actually to get you started in the right way. So what are integrals? They are the exact opposite of derivatives. So I'm going to put the link to my derivatives video in the bottom, but to do integrals you need to know what derivatives are. So if I said the derivative with respect to x of, let's say, x cubed, what would you do here? First, we know that you would bring the 3 down, so multiply everything by 3, so you have 3 times, and then decrease the exponent of the x by 1. So from 3, it would become a 2 because you subtract 1, so we would have 3 times x squared. So that would be the derivative of x cubed. So I'm going to say here, derivative. Okay, now, what is the integral? Like I said, it's the exact opposite, so we try and go back from this to this, and then this is a sign of an integral. It kind of looks like a squiggly line. But if I ask you what is the integral of 3x squared with respect to x, so this dx is the exact same as this. It just means with respect to x. X is the variable that we are interested in. So this would become equal to x cubed. But we're not done yet. So we're done basically 95% of the way. But one more thing you have to be careful of when dealing with integrals is called the constant of integration. What this means is that, let's say you had a derivative. So I'm going to write it here, derivative of x cubed plus 7. Now, if you take the derivative, this would become, once again, this is 3x squared, because you know from here, 3x squared, but then the plus 7 would go away, because derivative of 7 is 0. So this would be our derivative. But how do you know when you're going from this to this that we did not have a constant? We could have had plus 7, we could have had minus 7, we could have had plus 10, minus 10, we could have had any number being added, and it would still give us the exact same integral. So if you want to go back from the integral to the derivative, you have to add this constant, because it basically tells you that we do not know what could have been added because we're going back. But we're just saying that there could be the possibility of something being added for this to work. Okay? But yeah, so as long as you know this, and as long as you understood everything I said, you basically know how to do the integral. So first, you do the opposite of a derivative, and then you add the constant of integration. And that's literally it. So let's move on to a few examples now. Okay, question number 1. Here we have the integral of 2x with respect to x. Once again, with respect to x just means that we are interested in x. It is a variable that we are concerned with. But yeah, if you want to find the integral of x, first, let's see what we would do if you were trying to find a derivative of some exponent. So let's say we had x to the power of 7 and you wanted to find the integral of that. First, you would multiply. So you would multiply 7 times x to the power of, and then decrease the exponent by 1. So instead of a 7, this would be a 6. That's a derivative. You would multiply first and then subtract. For an integral, you flip these and you do the exact opposite. So what you do first is you would add instead of subtract. So for integrals, you would add first, and then you would, instead of multiply, you would divide. Add, divide. So let's try that. First, you have 2x. So this is equal to 2x. First, you want to add the exponent. So instead of x to the power of 1, add the exponent of 1 by 1. So you'd have x to the power of 2. And then divide by this new exponent that you have here. So what is this entire thing divided by 2? It's that. But then you also have to remember the constant of integration, because that's just a rule for integrals. So plus c. Let's do a bit of simplifying. If you have 2x squared divided by 2, this is the exact same as just x squared, because the 2 and 2 go away. And you have x squared plus c. This is the integral of 2x. And this makes sense. If you now take the derivative of x squared, you are going to get 2x, and the c goes away because it's a constant. It's a number. So that's what integration looks like. So first we added, and then we divided. We added the exponent, we made it from a 1 into a 2, and then we divided by the new exponent that we have. You bring the 2 down here, and that's it, and you're done. So that's question number 1. Question number 2, the integral of 6x with respect to x. Let's do the exact same thing. So first, rewrite your whatever is in here. So we rewrite 6x, and now we have to add the exponent first. So here we have x to the power of 1. This would become x to the power of 2. After that, you divide by the exponent, so divide by 2, and then add the constant of integration. And you're done once again. Let's simplify a bit more. 6 divided by 2 is 3, so you'd have 3x squared plus c. And you are done. That's question number 2. Pretty easy so far. Question number 3, the exact same thing. So let's start off with rewriting 3x squared. And now, instead of squared, we are going to increase the exponent by 1. So this would become to the power of 3. And then after that, divide by the new exponent. So divide by 3 and add the constant of integration. And once again, we're pretty much done. Let's simplify a bit. The 3 and 3 go away. So we'd have x cubed plus c. And you are done. Pretty simple. Question number 4, same thing. So you'd rewrite down the entire thing, 1 over 6 x to the power of 4. After that, what you can do now is add the exponents. Instead of 4 plus 1 is 5. So we can write down the 5 and then divide the entire thing by the new exponent, which is a 5. And then add the constant of integration. So let's do a bit of simplifying. 1 over 6 divided by 5 will become, is equal to 1 over 6 times 5 times x to the power of 5 plus c. Once again, I'm just dividing here, so if this is confusing, just divide this entire thing by 5. I'm simplifying. And then this will give you 1 over 30 x to the power of 5 plus c. Once again, you have to remember the plus c, because if you forget it, that's kind of like half the mark gone. It's kind of like a unit. For integrals, this is your unit. You cannot forget it. Okay, question number 5, same thing. So this would be, first write the entire thing down. So 7 over 5 x to the power of 6, and then start modifying it. So the 6 would first become a 7, and then divide the entire thing by 7, because that's the new exponent, and you bring it down. After that, let's do a bit of simplifying. So this 7 and this 7 cancel, and do not forget the constant of integration, so plus c, and then this will give you 1 over 5 x to the power of 7 plus c. Pretty simple and very easy. Now we're done with kind of the easy ones. All these ones were kind of stereotypical. They're the easy derivatives and integrals that you would usually see. Now we have 2 exceptions to this rule. Not every time you're going to add an exponent and divide by it. That's not always going to be the case, because if you remember, for some derivatives, it wasn't always the case where you brought down the exponent and you subtracted 1. That wasn't always the case. For some of them, let's say the derivative of sine x, if you wrote that, derivative with respect to x of sine x, this would have become cosine x, because that's just some exception to the rule of derivatives. And the exact same thing applies for integrals. If you're trying to find the integral of cosine x, this would be kind of, you have to go back. This one needs a bit of memorizing. There's no explanation to it. But derivative of cosine x is going to be sine x. But in this case, you also still have to remember your constant of integration. So plus c. Once again, this part applies for all integrals. This is not an exception. This applies for all integrals. But to find the first part is a bit varying, because it depends on the question itself. But that's that question. Pretty easy, but you have to memorize the derivative to know the integral. Question number 7. This one is almost like a trick question, but once again, you have to memorize the derivative to know the integral. I know this because I memorized it, but derivative with respect to x of ln x, ln x, would have usually been 1 over x. So if you want to go back and take the integral of 1 over x, this would be the opposite. So go from this to this would be ln x, and then obviously, once again, add the constant of integration, and you are done. So these last 2 were kind of exceptions, and you're going to notice this a lot with sine, cosine, tangent, and all the weird functions. But then if you have the easier ones with just a constant and an exponent like all of these, then you can follow this rule of adding and then dividing. But yeah, that's basically it for this video. Hopefully you understood. My next video is going to be more complicated examples where you kind of need to think and there are rules that you need to follow to actually be able to solve them. But yeah, so that's it for this video, and I hope you understood.